Okay, we'll go through some important points in class 11 physics chapter 6 work energy and power. Okay, somebody who has a capacity to work for these hours is said to have a large stamina of energy. Large stamina or energy. The scalar product or dot product of two vectors A and B denoted as A dot B. A dot B is AB cos theta. Okay, and theta is the angle between A and B, the two vectors. Here B cos theta is the projection of B on A, and A cos theta is the projection of A on B. This is a distributive property. A dot B equal to 0 if A and B are perpendicular, that is AB cos theta, theta is 90, cos 90 is 0, so it will be 0 when perpendicular. Here they are finding the angle between the two vectors f dot d. This is how they are finding dot product. Then the magnitude of f, magnitude of d. F dot d equal to fd cos theta. So cos theta equal to f dot d by fd. This is fd. So f dot d by fd. Okay, theta. We can find theta from this number. So this is the projection of B on A. This is the projection of A on B. This is one of the kinematic equations, initial and final velocities. Okay, and this acceleration displacement. The change in kinetic energy is the work done. Okay, initial and final kinetic energy. The change in kinetic energy of the body is equal to the work done on it by the net force. So here from this question, we have to understand change in kinetic energy is the work done by the gravity and work done by the resistive force. Okay, so from this we can find out work done by the resistive force, subtracting change in kinetic energy, the gravitational force. This formula is important. Work done equal to fd cos theta. So when in which situation work done is 0, displacement can be 0, force can be 0, or both are in perpendicular cos 90, that is 0. Frictional force is always opposite to the displacement, that is 180 degree. Moving in the right side, the frictional force opposes it is 180 degree. Work energy dimensions. Okay, here in the cyclist come to skating. Okay, what is the work done? The stopping force and the displacement is this. Their stopping force and the displacement is angle is 180 degree. Cos 180 is -1. So this is the negative. See now here the work done by the cycle on the road is 0 because this road undergoes no displacement. So d is 0. That is why work done by the cycle on the road is 0. Fd cos theta d is 0. So work done 0. Kinetic energy is scalar quantity. See, this is the law of conservation of the energy. So you will see that the speed is reduced by approximately not by the how much energy is reduced. The energy and speed reductions will be different here. Summation to integration here. and delta T is 0. Area under this curve is the work done. This is the force and the displacement. FD cos theta. This is area under curve is the work done. So here they are finding the work done by finding the area under the this trapezium, the area of the trapezium, how they are finding. Change in velocity is the acceleration. Change in kinetic energy is the work done. How they are converting this integration into the natural logarithm ln. Potential energy brings on to the stored energy. Potential energy means is stored energy. This potential energy is released in the form of a kinetic energy. This is the potential energy due to the gravity mgh, and the velocity at which object reaches the ground, v equal to square root of 2gh it will come. Shows that gravitational potential energy of the object at height d when the object released manifests itself as a kinetic energy of object reaching the ground. Law of conservation. Work done by a conservative force such as the gravity depends on the initial and final positions only. Path independent. Dimensions. Total energy initial, total energy final. That is kinetic energy plus potential energy. The total mechanical energy of the system is conserved. The forces doing work are conservative. So here at this point only potential energy, in between potential energy plus kinetic energy, here at the ground only kinetic and no potential energy because height is 0. mgh is the potential energy. At the ground height is 0, so potential energy will be 0. These are at 3 points, but the total energy is conserved here. This energy here potential plus kinetic, here kinetic energy only. All these three energies are same. The energy is purely potential. It is partially converted to kinetic energy at the middle, that is H, and fully kinetic at the ground level. This gravity and in this spring, gravity and tension are the opposite sides. The snow due to the displacement always normal to this string. Tension is opposite the gravity. This is the spring force, spring constant into displacement. Okay, this is spring constant. So at equilibrium, this force is 0, display the work done is 0. Here positive, x is positive, f is positive. Okay, here string is compressed, x is negative, f is positive. Here x is positive, f is negative. So the area under this is the work done. The energy stored area equal to half into base bh into height, that is kx. So base that half 1 by 2 into kx square. Equilibrium position. Okay, this is the work done. Spring force is also conservative force. This is how the energy of the spring varies. Okay, conservative force, energy kinetic plus potential energy. This is potential energy, and this is K is kinetic energy, and this one is the potential energy. When you add up both the two, then they are constant. Maximum compression, the kinetic energy of the car is converted entirely into the potential energy of the string. The frictional force is a non-conservative force. It is a path dependent force. Okay. Kinetic energy, the other configuration is position, potential energy, kinetic energy, potential energy. Total energy of the reactants is more than the products of the reaction. Heat is released. The reaction is exothermic. Heat is released, exothermic. That is, heat is absorbed, then endothermic. These are the various things how much energy is released. To break the one bond of DNA, this much energy. This is joules to electron volt conversion. 10 power minus 19 joules is the 1 electron volt. 1.6 into 10 power minus 9 joules. Human consumption in a day in terms of kilocalories. Power is defined as the rate at which work is done or the energy is transferred. Rate at which work by time. Okay, this is instantaneous power. Power, work and energy dimensions. Collisions. Implied this is a initial. Mass m1 with stationary mass m2. The collision, after the collision they are going in the opposite directions. Elastic, inelastic collision. In all collisions the momentum is conserved in both the cases, elastic as well as inelastic. Initial kinetic energy is equal to the final energy, but the kinetic energy during the collision time is not constant, that is a small time, delta t. Elastic collision. Completely inelastic means after the collision they move together. Inelastic collision. Okay, this is inelastic collision, momentum is conserved, but the kinetic energy is lost during inelastic collision. These are the momentum and the energy conservation equations. velocity exchange in elastic collision if masses are same. Say vector. If the initial and final velocities of both bodies are along the same straight line, then it is called a one-dimensional collision, head-on collision. If the initial and final velocities of both bodies are along the same straight line, then it's head-on collision. This is a Q, it's called a Q and the target. When two equal masses undergo the elastic collision on the address, after the collision, they will move at right angle each other. Go through the summary. This is important points. Is okay. Very important. You should read these points to ponder. The phrase calculate the work done is incomplete because you have to say work done by whom to say cycle and road. You have to say explicitly what is the work done by the cycle on the road or work done by the road on the cycle. Okay. The space calculate the work done is incomplete. We should refer or imply clearly by context. Okay. The work done by the specific force on the group of forces on the given body, okay, over the certain displacement. Work done is a scalar quantity. It can be positive, negative, okay, but mass and kinetic energy are positive quantities. Work done by the friction or viscous force is moving body is negative. Work done by the friction is negative. For two bodies, the sum of the mutual forces exerted between them is 0 from the Newton's their law. That is, two bodies, the sum of the mutual forces is 0. But the sum of the work done by the two forces need not be always cancelled. That is, work done on 1 to 2, work done on 2 to 1 need not be 0. However, it may sometimes be true. The work done by the force can be calculated sometime even if the exact nature of the force is not known. This is clear from the example. Okay. Work energy theorem. Work energy theorem is not independent of the Newton's second law. Work energy theorem may be viewed as the scalar form of the second law. The principle of the conservation of the mechanical energy may be viewed as the consequence of the work energy theorem for the conservative forces. The work energy theorem holds for all initial frames. It can also be extended to the non-initial frame provided. Okay. The potential energy of a body subject to conversion is always determined up to this constant. For example, point where the potential energy is 0 is a matter of choice. For gravitational potential energy, mg is 0 and is chosen to be the ground. On the ground, mgh will be 0 because h is 0. For the spring, potential energy k square by 2 0. The potential energy in the equilibrium position. Okay, so for spring, the potential is 0 at the equilibrium position, but gravitational potential energy will be 0 at the ground level. Okay, every force encountered is a frictionless does not have an associated potential energy. For example, work done by the frictional over a closed path is not 0 and no potential energy can be associated with the friction. During the collision, the total linear momentum is conserved at each instant of the collision. Okay, the kinetic energy conservation, even if the collision is elastic, applies after the collision is over. Okay, does not hold the every instant of the collision. In fact, the two colliding objects are deformed and may be momentarily lost with respect to each other. Okay.